In Chapter 4, Segment 3, Effects on Transmitter Receptors, receptor antagonists bind directly to postsynaptic receptors and block them from being activated by their neurotransmitters. By bonding to specific receptors and activating them, selective receptor antagonists mimic the natural neurotransmitter of those receptors. For example, LSD by causing extreme visual experiences through stimulation of a subtype of serotonin receptor found in the visual cortex. In effects on cellular processes, neurotransmitters can stimulate a variety of changes within the postsynaptic cell by binding to their matching receptors on the postsynaptic membranes. For example, activation of second messengers, production of various proteins, and activation of genes. Some drugs cause an increase in the postsynaptic cell's receptors, which changes the sensitivity of the synapse, and others cause a downregulation of receptor density. Some drugs can also directly alter second messenger systems. This might be how mood-stabilizing drug lithium chloride acts. In antipsychotics relieve schizophrenia, antipsychotics are defined as a class of drugs that alleviate the symptoms of schizophrenia. Examples like chlorpheniramine, haloperidol, and loxapine act as selective antagonists of dopamine D2 receptors in the brain. Typical antipsychotics are a class of anti-schizophrenia drugs whose principal mode of action is antagonism of dopamine D2 receptors. They relieve the positive symptoms of schizophrenia. Atypical antipsychotics are a class of anti-schizophrenic drugs that have actions other than or in addition to the dopamine D2 receptor antagonism that characterizes the typical antipsychotics. They have both dopaminergic energy and non-dopaminergic actions, like the blockage of serotonin receptors. They reduce the negative symptoms of schizophrenia. Evidence now shows that schizophrenia involves more non-monoaminergic mechanisms. In antidepressants reduce chronic mood problems, it says that mood disturbances or affective disorders are the most common of psychiatric complaints. Antidepressants are a class of drugs that relieve the symptoms of depression. The first class are monoamine inhibitors. MAOs break down monoamine neurotransmitters at axon terminals, reducing transmitter activity. By blocking this process, MAO inhibitors allow monoamine neurotransmitters to accumulate at synapses with improvement in mood. The second class is tricyclics, which are a class of drugs that act by increasing the synaptic accumulation of serotonin and norepinephrine. Tricyclics break the reuptake of neurotransmitters into presynaptic axon terminals, allowing the transmitter to accumulate in the synapse. Most recently developed selective serotonin reuptake inhibitors and serotonin norepinephrine reuptake inhibitors. Serotonin reuptake inhibitors are a drug that blocks the reuptake of transmitter at serotonergic synapses. Serotonin norepinephrine reuptake inhibitors are a drug that blocks the reuptake of transmitters at both serotonergic and noradrenergic synapses. They alleviate depression by selectively allowing serotonin and sometimes norepinephrine to accumulate in the synapses. They can take a full 6 to 8 weeks to function and have less side effects. In Anxiolytics Combat Anxiety, it says that clinical states of anxiety include panic attacks, phobias, and generalized anxiety. Anxiolytics are a class of substances that are used to combat anxiety. They belong to the general class of depressants, which are a class of drugs that act to reduce natural activity. Alcohol and opiates were once the original anxiolytics, but they have increased risks of intoxication, addiction potential, and neurophysiological impairment. Barbiturates are a powerful sedative anxiolytic derived from barbituric acid with dangerous addiction and overdose potential. They were originally used to reduce anxiety, promote sleep, and prevent epileptic seizures. Benzodiazepine agonists are a class of anti-anxiety drugs that bind to sites on GABAA receptors. They are safer and more specific than barbiturates. They bind to GABA receptors and enhance the activity of GABA and reduces the excitability of neurons. GABAA receptors have several different binding sites. Some facilitate and inhibit the effect of GABA. An orphan receptor is any receptor for which no endogenous ligand has yet been discovered. For example, benzodiazepine binding site. Allopregnanolone is a natural occurring steroid that modulates GABA receptor activity in much the same way that benzodiazepine anxiolytics do. Alcohol ingestion increases brain concentration of allopregnanolone, so this steroid can mediate the calming influence of alcohol. In Opiates Potently Relieve Pain, it defines an opium as a heterogeneous extract of seed pod juice of the opium poppy. Morphine is an opiate compound derived from the poppy flower. It's an effective painkiller that brings relief from severe pain and has strong potential for addiction. Heroin, or diacetylmorphine, is an artificially modified, very potent form of morphine. It has strong potential for addiction. Morphine, heroin, and codeine bind to opioid receptors that are concentrated in certain regions of the brain. It's found in limbic and hypothalamic areas of the brain and are rich in the locus coeruleus and the periaquedural gray. The periaquedural gray is a neuronal body-rich region of the midbrain surrounding the cerebral aqueduct that connects the third and fourth ventricles, which is involved in pain perception. There's a lot of scientific effort to identify endogenous opioids. Endogenous opioids are a family of peptide transmitters that have been called the body's own narcotics. The three kinds are enkephalins, endorphins, and dynorphins. Enkephalins relieve pain and are addictive, but only have a small portion related to the morphine molecule, but that is the part that binds to the opioid receptor. There are three kinds of opioid receptors, delta, kappa, and mu, and they are all metabotropic receptors. Opioid antagonists can block the rewarding sites of drugs and can help in treating addiction. In some neuroactive drugs are used to alter conscious experiences. It says that the major class of neuroactive drugs that modify consciousness include cannabinoids, stimulants, alcohol, and hallucinogenic and dissociative drugs. And cannabinoids have a wide array of effects. It defines marijuana as a dried preparation of the cannabis sativa plant typically smoked to obtain THC. 9-tetrahydrocannabinol, or THC, is the major active ingredient in marijuana. It usually produces relaxation and mood alteration, but can occasionally cause stimulation and paranoia. Heavy use can be associated with respiratory problems, addiction, psychiatric disorders, and cognitive decline. Adolescents that use marijuana have been shown more likely to develop psychosis in adulthood. The brain contains cannabinoid receptors that mediate the effects of compounds like THC. They are located heavily in the substantia nigra, the hippocampus, the cerebellar cortex, and the cerebral cortex, and even the brainstem shows few of the receptors. There are at least two subtypes of cannabinoid receptors, CB1, which is found in the nervous system, and CB2, found in the immune system. An endocannabinoid is an endogenous ligand of cannabinoid receptors, thus an analog of marijuana that is produced by the brain. It can function as retrograde messengers that convey messages from the postsynaptic cell to the presynaptic cell. An anandamide is an endogenous substance that binds the cannabinoid receptor molecule. It can alter memory formation, stimulate appetite, reduce sensitivity to pain, and protect from exotoxic brain damage. Even though cannabinoids have been used for over 6,000 years, it still remains illegal in many jurisdictions. And stimulants increase the activity of the nervous system. Stimulants are drugs that tip the balance towards the excitatory side. They have an alerting, activating effect. For example, amphetamine, nicotine, caffeine, and cocaine. Some stimulants act directly by increasing excitatory synaptic potentials, while others act by blocking normal inhibitory processes. Stimulants such as methylphenidate have a common effect in humans with ADHD, which may be caused by mediated changes in serotonergic energy. Nicotine is a compound found in plants, including tobacco, that acts as an agonist on a large class of cholinergic receptors. From cigarettes, nicotine enters the blood and brain more rapidly than nicotine from other tobacco products. It increases heart rate, blood pressure, secretion of hydrochloric acid in the stomach, and intestinal activity. In adolescence, prolonged smoking and nicotine exposure result in a lasting impact on attention and cognitive development. Nicotinic receptors drive the contraction of skeletal muscles and the activation of many instinctive organs, but many are also found in the brain. This is the reason why it enhances some aspects of cognitive performance. Nicotine ACH receptors act directly on the ventral tegmental area to exert its rewarding, addicting effects. Cocaine is a drug of abuse derived from the coca plant that acts by potentiating catecholamine stimulation. It results from smoking or snorting, has a stimulant effect that is powerful and pleasurable while being highly addictive. Crack is a smokable form of cocaine that enters the blood and brain even faster than regular cocaine, which makes it more addictive and dangerous. Heavy cocaine use raises the risk of serious side effects such as stroke, psychosis, loss of gray matter, and severe mood disturbances. It acts by blocking monoamine transporters, slowing the reuptake of transmitters and therefore boosting the effects. Stopping of cocaine use produces uncomfortable withdrawal symptoms such as initial agitation and powerful drug cravings before transferring to depression and an inability to enjoy life. Cerebral glucose metabolism is decreased for months, which may contribute to the depression. Dual dependence is also a risk of usage of cocaine. Dual dependence is dependence for emergent drug effects that occur only when two drugs are taken simultaneously. Amphetamines are a molecule that resemble the structure of catecholamine transmitters and enhances their activity. It causes the release of transmitters from presynaptic terminals, even in the absence of action potentials, and when action potentials do reach the axon terminals, amphetamine also potentiates the subsequent release of a transmitter. After the transmitter molecules are released, amphetamine enhances the activity by blocking the reuptake of catecholamines in the presynaptic terminal and providing an alternative target for the enzyme that normally inactivates them. Prolonged use may lead to symptoms that mirror paranoid schizophrenia, such as compulsive agitated behavior and irrational suspiciousness. It also acts with the autonomic nervous system to produce high blood pressure, tremor, dizziness, sweating, rapid breathing, and nausea, while also having brain damage even long after they quit. In alcohol, it acts as both a stimulant and depressant. It says that excessive alcohol consumption is very damaging and linked to more than 60 disease processes, making it one of the top 3 risks to health worldwide. Alcohol has a biphasic psychoactive effect, which is an initial stimulant phase followed by a more prolonged depressant phase. Alcohol activates the GABAA receptor coupled chloride channel, which increases postsynaptic inhibition. Chronic alcohol abuse damages neurons. Alcohol use in expectant mothers can cause permanent brain damage to the developing fetus, also known as fetal alcohol syndrome. Fetal alcohol syndrome is a disorder including intellectual disability and characteristic facial anomalies that affect children exposed to too much alcohol through maternal ingestion during fetal development. The frontal lobes are the brain areas most affected by chronic alcohol use, but some of the anatomical changes that occur during alcoholism can be reversed with abstinence. There is a strong hereditary component to alcoholism. Even binge drinking 5 or more drinks on a single occasion may cause brain damage. It also significantly reduces the formation of new neurons.